I'm going to draw a vector here that is 20 meters to the east. I'm going to draw another vector that's to the west. What do you know about that second vector? We know that it's negative. If we're adding them together in one dimension, we consider it to be a negative value, absolutely, because it's the opposite direction. Good. What else do you know about it? Yep. We know it's smaller than 20. It looks like it's somewhere around 10, but we don't know exactly because we didn't measure it. We'll say it's 10 meters. But again, when we're adding these together, we make it negative 10. What if I had one that was like this? It looks like it's longer than the 20, right? Maybe it's 30 meters. We would make that negative because it's downwards? Kind of, but we couldn't just say 20 plus negative 10 plus negative 30, could we? Or could we? No, because if we're adding vectors in two dimensions here, right? If I'm adding 20 plus 10, it's easy enough to say 20 plus negative 10 is equal to 10. But if I'm adding the 20 plus 10 plus 30, I've got to add these together in two dimensions. What's the goal? What's always the goal when I'm adding vectors in two dimensions? Yep. We always want to get a right angle triangle. Now, if I combine these, I'm not going to get a right angle triangle right away, but I'm going to be close. So let's start trying to combine them here, okay? Let's say we got 20 meters. We got 30 meters. And then we got 10 meters. Is that okay? We don't have a right angle triangle, but we can combine those to make a right angle triangle, right? Am I good so far, though, or have I made a mistake here, Janae? Good. Can't do that because the vectors have to be drawn head to tail. This was drawn head to head. So I can draw that other 10 meters in here, or I could draw that 10 meters up there, but I think it's probably easiest to draw right here. My resultant vector, by the way, which I usually make red, my resultant vector will be drawn from, yep, the start to the finish. So it's going to look like this. Now, we can't find the magnitude of that resultant vector or the direction yet until we get that right angle triangle. So let's work on getting that right angle triangle now. How do you do that? Yep. Yeah, do the x and y components. So you tell me, just out loud here, guys, you don't need to put up your hand for this. Tell me what the x component is of the 20. Plus 20. What's the y component of the 20? 0. What about the 30? X? 0. The y is? Why is it negative 30? Because it's downwards, right? So somebody said it was negative before. Yeah, we can make it negative, but we got to make it negative in the context of a two-dimensional problem in an x and y component here. What about this 10 meters? X is negative 10 because it's to the left. The y is 0. We add these up, we get 10. We add this up, we get negative 30. And now we redraw this 10. 10 to the right. And 30 down. How did I know to draw that 30 down there? How did I know not to make it 30 up? Because it's a negative value, right? So we're going to draw our resultant vector here now from start to finish. Black ones are drawn from head to tail. The red one is drawn from start to finish. What do we got here now? Well, we've met our goal because we've got a right angle triangle. We can deal with that right angle triangle, right? Solve for r by using the Pythagorean theorem. Whatever that works out to be, I'm not sure. Theta is the inverse tan function of opposite over adjacent. What's the opposite side of this triangle, 10 or 30? 30 is the opposite side. It's the one that's not touching the angle. Opposite is always the one that's not touching the angle. Adjacent, that's a little bit trickier, actually, because you get two sides touching the angle here. But the resultant vector is always the long. That's not true. The hypotenuse is always the longest one. Resultant is usually the longest one, not always. The hypotenuse is always the longest one, and the adjacent is the other one. So we're going to say that the opposite is 30 and the adjacent is 10, and we'd solve for that angle, whatever it worked out to be. How would we express that angle? Whatever degrees what of what? Well, where'd we go? Which way is this? Right or east? Which way is this? So we went east and south, right? Which one did we go first? Well, if we go around the angle here, we went east. We went east and south. So we went south after we went east, right? South after east or south of east. So whatever angle that is, we measure it south of east. Now you could have drawn it like this. You could have drawn 30 and then 10, and then you would have gotten an angle right here. This would have been the complement to this. So if this worked out to be 40, this would be 50 east of south. That make sense? All right. Get a right angle triangle. Sometimes we can get it right away. Sometimes we can't get it right away. Sometimes we've got to break it into X and Y components in order to get that right angle triangle. What if we got a situation like this, where we have a vector that's 10 meters, we have a vector that's 5 meters like this, and then we have a vector that's, we'll make it 8 meters like this, at an angle of 30 degrees. What do you see there? I heard somebody whisper it. I don't like funny angles. They got a funny angle. I don't like it. So I take it off to the side. I put it out of its misery here. 30 degrees. Let's label this as X because it's the X component. This is Y. And of course, the hypotenuse is 8.0. So let's find the X component by saying cosine 30 degrees is equal to adjacent over the hypotenuse. And let's find the Y component by saying sine 30 degrees is equal to opposite over hypotenuse. This one I know works out to be 4.0. This one, 8 cosine 30, I'm not sure what that one is. 8 cosine 30 gives me 6.9282. Now, what I would do is just simply replace this with something that makes a little bit more sense, something that we like a little bit more. 6.9282 to the left. We know it's to the left because right, that 8 meters per second, or that 8 meters goes left and up. So 6.9282 is to the left, 4.0 is up. Now it's easier, right? Now we got a problem just like we just solved with just a few vectors, and we have to break it into X and Y components. So let's do that now. Just give me the numbers here, guys. What and what for the first 10? 10 and 0. Good. What and what? 0 and -5. What and what? Negative 6.92. It's negative because it's to the left. And 0. And what and what? What's the 4? How much of it's X? 0. And how much of it's Y? 4. So we're going to add these up. What do we get here? 10 minus 6.92. 3.0718. And we add these up. This one's easy, -1. We redraw it. .0718 and 1 down. And look at what we end up with. A vector that looks the same as the vector that we just had. But now it's part of a right angle triangle. So we know how to deal with it, right? R and theta. Theta is in position 1, 2, or 3. 1. And it's in position 1. We know that because it's the start of my vector diagram. You guys find R there? You guys find theta? Square root of 3 squared plus 1 squared. Theta is the inverse tan of what over what? 3 over 10 or 10? Sorry, 3 over 1 or 1 over 3? What's the opposite side here? 3 or 1? It's 1. So we'd say the inverse tan of 1 over 3, whatever that works out to be. And we'd say that that would be expressed south of east. South of east because we went east, then we went south, or we went south after we went east. Good? You guys feel like you do a quiz on that tomorrow? Okay, let's see. Okay, let's see. Let me give you a question here that we'll call a practice quiz. Doesn't count for anything, but it'll be remarkably like the quiz you'll get tomorrow, including the same number of questions. 1. I want you to add these vectors together. Okay, there we go. Let's see what you get on that, okay? Give you a few minutes to work on it, and then we'll check it over as a class. All right, time to go over this. What's the first thing we see here? Whatever it is, I don't like it. You got a funny angle, so let's take it off to the side here and get rid of it. 50 meters over here. We're at 30 degrees here, so let's draw a triangle. Can we draw the triangle like this? Does that make sense? Like, technically, I've got a right angle drawing there, and it's drawn head to tail, but I don't want to draw like that, right? How come? Yeah, you could. You could flip the angle and make that 60 degrees in here and make that work. Yeah. I don't want to do that, though. I want to draw my triangle around the angle. I want to draw it such that the angle is inside the triangle. So it's going to be like this. This is going to be x. This is going to be y. I want to say cosine 30 degrees is equal to adjacent over hypotenuse. X is the adjacent side. The 50 is the longest side. It's the hypotenuse. The adjacent side is the other one that's touching the angle. So we're going to say this one is 43.3 meters. And sine 30 degrees is equal to opposite over hypotenuse. Y is going to equal 25 meters. Walk this off to the side. And now let's replace this. Let's replace this with, what do we got? 43.3 and 25 upwards. Now we can deal with this, right? Pretty easily. Okay, just give me some numbers here. What and what of the first one? How much of it's x? None of it. How much of it's y? Negative 100, because it's all downwards here. Okay, second one is 50. How much of it's x? 50. Positive 50, because it's to the right. None of it's y. This one is 0x and 50y. This one is 100x, right? Is that right? No, what's wrong with it? Negative 100, because it's to the left, and it's 0y. Then we have negative 43.3 to the x and 0 to the y. And then we have 0 to the x and 25 to the y. So we start adding these things up now. What is that? 50 plus negative 100 plus 40, negative 43.3. I think it works out to be negative 50, negative 93.3. And this one is what? 25, I think. Now it's the easy part, right? Negative 93.3. That's to the left. I know that's to the left because it's negative. And 25 up. Listen, now we just do the Pythagorean theorem to get r, right? And where am I going to label the angle? 1, 2, or 3? Rachel? It's what, sorry? Oh, is that negative 25? Oh, it is. Oh, thank you. It is negative 25 because it's, when we add them up mathematically, it's negative, which means that this is 93.3 and 25. It's not going to change the value of r, actually, though, is it? R is going to be the same, at least the magnitude of it is, but the direction isn't going to be the same. So R, what does R work out to be there when you do the math? 96.5, so 97 meters. And the angle would be the inverse tan of, what is it going to be? 93 over 25, 25 over 93. 25 over 93, it's opposite over adjacent. Opposite is the side that's not touching the angle. And the adjacent, well, it's not the hypotenuse, it's the other side that is touching. And what do we get for that angle? 15.5, 16 degrees. And we'd express that 16 degrees what of what? Which way do we go? To get to this point, we went which way? West, then south after west, or we'd say south of west there. Good? You good there? Let's quickly go through these two questions that you had for homework here, at least the structure of them. We got this 5 meters. It's at 30 degrees right here. Let's label this as x. This is y. X is going to be 5 times cosine 30. Cosine to give me the adjacent side, which is going to give me 4.33. And y is going to equal 2.5. So we're going to do this. 2.5, 4.33. And then we're going to get rid of these, right? Now you can do your thing, right? X components, y components. And then you're going to do the Pythagorean theorem in the inverse tan function. Next one. Got a similar thing in the next one, except question number 16 has 2 funny angles. We got to take them both off to the side. Here's the 60-degree one. Let's call this x, this y. We're going to say that sine 60 degrees is equal to x over the hypotenuse, which was 5. And x is going to be equal to 4.33. Y is 2.5 because it's the opposite side. Sorry, the adjacent side. So we're going to do this. 4.33 and 2.5. Scratch that out. It's gone. And then we're going to do the other one. We're going to say this one is down like this, 20 meters, 30 degrees. X and Y. X is going to be equal to 17.32, which is 20 cosine 30, and Y is going to be equal to 10. Let's replace this with 17.32 and 10. And then let's scratch all this out. Now it's just a matter of doing exactly what we've done for a number of these questions, combine the X's and Y's. Good? We're good with that one? You guys feel like 100% on tomorrow's quiz? 100? Yeah. How do we do the direction naming? Okay. Okay. Tell you what, let's just finish this one off. Let's finish this one off. And then we'll name the direction at the end of this one, okay? So X's and Y's. First one is -10 and 0. 0 and -10. 4.33. 0. 0 and 2.5. Got lots of them here. 17.32. 0. 0 and 10. -10. Good, because it's downwards. Oh, what does that equal? 21.65, 11.65, -17.5. So we draw 11.65, 17.5 down. Do we need to label the negative there, by the way, on the 17? No, the arrow on the vector shows us the direction. We don't need to label it as a negative. Solve for r there, and we solve for theta there. R works out to be, let's do this in the calculator here, the square root of 11.65 squared plus 17.5. Notice I didn't even put the negative in there. Square root that. 21. And find theta by saying the inverse tan function. We should actually check. We're in degree mode. Sine 90 equals 1. Yep. Degree mode. The inverse tan of opposite over adjacent gives me 56 degrees. Now, Kyle asked for a little clarification on south of east, west of south, whatever it is. Look at our two vectors, the 11 and the 17. Where'd I go? This one is to the, this one's to the east, this one's to the south. So I went east and I went south. Which one did I go first, Kyle? Take a look at these vectors. Which one did I do first? East or south? I do east first, right? So I went south after I went east. Make sense? So I'm going to express that as south of east. Okay? Just replace the word of with after, or with, sorry, the word after with of. So if I went south after I went east, then I went south of east. Okay.